Today, first discussion is a range-based programs. See, so what is that range-based programs? What is that? Range-based programs and how can we implement? Look at this. I'm taking n equals to some value. Later we will fix the value. Then we are writing the code. If that n value is divisible by 2 equal to 0, then we are printing that number. Print that n is even. N is even. N is even. Sir, if it is a not even, I am not printing. Just I am checking that number is even number or not. But if the number is even number, we are printing that number. See, suppose if I am giving 4, it will give that message is a 4 is even. But if n is equals to 5, run, nothing is printing. Sir, why? See, this is the code is used to check the given number is even. If it is even, print it. But now the question is range based. Look at this. Now n value is not single value. I'm giving for n. Don't use I. Use n only. Sir, why n? Because you have written this logic using n, not using I. N in the range of 1 comma 20. Nothing but if they ask you to print even numbers from 1 to 20, 21 you have to give. It is giving 2 is even, 4 is even, 6 is even, like this. Nothing but within the range, even numbers if you want to print, we are writing this code. Look at this, is a 1. Next one is C. Again, they have given one number. Again, whatever the number, we don't want. I want to print multiplication table for that number that we have already discussed. What is that? Using the for loop. 10 times we have to repeat for I in the range of 1 comma 11. Total 10 times we are repeating. And we are printing formatting. Table number is multiplied with the I value equals to n into I value. Suppose if I am giving that n value is a 5. N value is a 5. Here it is a fifth table will print. If I give n value is a 13, here it is a 13th table will print. Suppose the question is, sir, I want to print tables from 7 to 13. So this logic, again, look at this. Inside this outer loop, now loop is added for, again, don't use I. Because this is the logic for printing nth table, n. So outer loop always n. N in the range of, suppose 7 to 13 means 7 comma 14 I am giving. So what will happen? First n value starts with a 7. So first 7th table will print. Then again it will go outer loop, n value become 8. Right? 8th table will print like this. 7, 8, 9, 10, 11, 12, 13. All the things it is printing. This is what? Printing the multiplication tables. Printing the multiplication tables in the given range. Next one is for the given number, whatever the number again, I want to print factorial value. This one also we have already completed in for loop. Taking that fact value, you are multiplying, so fact equals to 1. You are repeating the loop I in the range of, suppose if it is a 5 factorial, up to 5 you have to repeat. Nothing but up to n. If n is a 5, you should give 6 here, nothing but n plus 1. If n is a 7, you should give 8 here, so n plus 1. Every time fact equals to, fact is multiplied with the I. And outside we are printing, print clearly that number factorial value, we are printing that fact. See, if n value is a 5, output is a 5 factorial 120. If n value is a 4, factorial value is a 24. Same story. I want to print factorials from 2 to 8. The complete code you need to write inside of the loop. Don't write fact value outside. I'll explain. For n in the range of from 2 factorial to 8 factorial I want. So 2 to 9. Output will be like this. 2 factorial 2. 3 factorial 6. 4 factorial 24. 5 factorial 120. Like this, factorials printing. If you print this fact outside, what will happen? Look at this. First, you are finding 2 factorial now. By that time, fact value become 2. Next, whenever you are finding 3 factorial, it will start from 2. But every time, factorial value starts with 1. So, never place outside. That's why, whenever you are writing range-based programs, first you have to write the code for one number, not multiple again. Blindly, if you start outer loop, now is okay. You have a computer. If you get a wrong output, simply you will change the code and you will check. But in interview, it will not happen. So that's why first you need to write this code. Then outside only loop you have to add. Outside nothing should be there. It's very, very important point. One more thing also, the same model, we have seen prime numbers. Checking one number is a prime number or not. Given number, n is a prime. Already we have seen. Prime number means what? If it has factors, for example, if it has a 2 factors, it is called prime. So we are counting how many factors are there. Just counting for I in the range of starting from 1 to itself. I'm just counting every time. If it is divisible, this logic already we completed in the for loop. Just increasing the count value. We are counting. After counting, I'm not printing the counting. I'm checking if count value equals to 2. If 2 factors are there, yes, it is a prime. N is prime. Suppose if I give 7, yes, 7 is a prime. Suppose if I give 6, 6 is not prime because factors 1, 2, 3, 6. 4 factors are there. Nothing is printing. Sir, why you are not printing? Not prime because I'm not checking 1 here. Look at this. Later, I just want to print prime numbers from 1 to 30. For n in the range of 1 to 30 means 31 will give. So every time 30 times this code gets executed. 30 times because outer loop repeat 30 times. See 2, 3, 5, 7, 11, 13, 17, 19, 23, 29 on prime numbers. Here also important story. Don't declare count value outside. Imagine what will happen. If you declare count outside, you never get that result. Because first time whenever you are finding that one is not a prime number. Next time whenever you are finding that 2 is a prime or not, count is not starts with 0. It is already 1. It starts with 1. It starts with a 1. So you will never get. That's why I told you that before this line, there is no statement should be present. Remember that. So first, you should be good at this logic. Once you are good at this logic, then only you are adding this outside logic. This is what printing the prime numbers from 1 to 30. Okay. Please do this. Now one thing. Here it is. There is a concept called perfect number. Perfect number means, suppose if you take one number, let us take n is equals to 6. Same just like the prime number. Here you need to find the factors for the given number. Repeat the loop from 1, 2, 3, 4, 5, 6. But no need to check with itself. Accept itself. Only remaining factors only you need to sum. 1 is a factor. 2 is a factor. 3 is a factor. Of course, 6 is a factor. But don't check with itself. Only remaining factors sum. Only remaining factors sum. Sum equal to 0. Now 1 will be added. First 1 is a factor. Some value become 1. Next 2 is a factor. 1 plus 2, 3. Next 3 is a factor. 3 plus 3, 6. Then finally you have to check if that n value and some value both are equal. Then we can say that it's a perfect number. It's a perfect number. It's a simply the sum of factors except itself. So here, what is the code we are writing? What is the code? First, taking one number, same 6 only I am taking. Sum we are finding. Take the sum value 0 and repeat the loop for I in the range of 1 comma. If you want to check with itself also, what we have to give? N plus 1 we have to give. But the question is what? No need to check with itself. So just up to n. 1 to n we are repeating. And we are finding, if that n value is divisible by I equals to 0, then add to that sum. Sum is equals to sum plus I. You are adding that value, that factor to the sum. And what we are printing outside, if some value and the given number both are equal, then simply we can say that it's a perfect number. Else, it's not perfect number. So n is a perfect number. So output is coming that it's a perfect. This is just finding that given number is a perfect number or not. The next one is within the range. See, I'm not printing this one. Just only I'm giving that n is a perfect. But I want to print perfect numbers. I want to print perfect numbers from 1 to 10,000 for n in the range of starting from 1 to 10,000. 10,000 means 10,001 I have given. Why up to 10,000 means what? It's a little important interview question. Because from 1 to 10 between, only one perfect number is there, 6. Between 1 to 100, two perfect numbers are there, 6 and 28. Between 1 and 1,000, three perfect numbers are there. Between 1 and 10,000, four perfect numbers are there. So this is what finding the perfect numbers in the given range. The speed of the calculation quickly you can find out instead of doing this manually is a 1. Okay, complete this one also.